maybe this is your notes for lesson 5.11. Topic is synthetic division. And you will either need loosely, you can copy these examples directly there, or you can print the worksheet out from the topics page, 5.11. Okay, first of all, synthetic division is an alternate method to divide a polynomial. You can only use it in some cases. That's when you have a first-degree binomial with a leading coefficient of 1. I'll talk about that a little bit more later. It does not always work, but when it works, it's quicker and easier than long division. So I'm going to give you an example of how. I'm not going to do a lot of explaining about why it works. It's a process. It's called an algorithm. If you follow the process, you will get the right answer. So the first thing is to have a couple of vocabulary words. This part of the division problem is called the dividend. And this part is called the, oops, that was called the wrong, divisor. And the answer to this is called the quotient. All right? So we have a couple of pieces of setup we have to do. The first thing we do is draw kind of a funny looking upside down division bar, like this. It needs to be big enough that you put in 2 lines of work here. All right? So it has to be 2 lines at least deep. And in the top, we take the coefficients from the divisor. We take the coefficients from right here, and we put them in order. So we put a 1 right there. That goes with the x squared. With the x, we put the coefficient 2. And then for the constant, we put negative 15. Okay? That's the first part of the setup. They always go in order, x squared, x, and then the constant. And then for the divisor, we take this number right here. That says x minus 5. And we put this over here, but we don't put negative 5, we put positive 5. So if it says minus 5 here, we do the opposite of that, and we put positive 5. And our next example, we'll have a plus there, and then we'll put a negative. So that's your basic setup. I also put a box right here under the constant. I always, they don't show this, and if you look this up online, it's not always there. But when you put this box here, it helps you remember that the number that ends up inside that box, under the constant, right underneath the constant, the box, is always your remainder. Okay? Now, we'll have some remainders of 0 in these problems and some without 0. Okay? All right. So once you get it set up, we'll put some bullet points over here for your steps. The first thing you do is you bring down the first number. You take this, you do this in red, you bring this down. Oh, it's not a 5, it's a 1. All right, easy enough. Second thing you do is you multiply that 5, this one, that 5 times that 1 right there. You get that answer, it's 5. You take that number and you put it here. Okay, you put it right there. All right, and then you repeat that process. So the next thing after that, the next step, is to bring, not bring down this time, we're actually going to add the negative 2 plus the 5 that we just wrote down. Add those 2 numbers, and you're going to get, this is going to be red also, you're going to get 3, negative 2 plus 5. And then you're going to multiply again, that original 5, again, this one, times the 3 that we just wrote down. And 5 times 3 is 15, and you put that number right here. Okay? Now we keep repeating that process for as long as the problem is. This is going to be our last step on this one because that's the end. We're going to add negative 15 to positive 15, and we're going to get 0. This problem has a remainder of 0. All right, that's the basic setup for synthetic division. Then you have to take that answer, what's written there, and say, well, what does that mean? Well, we started off by dividing an x squared, right there, and we divided it by an x. So what's going to happen every time we do this is this power right here is going to go down by 1. This 1 right here is going to get attached to an x, and this 3 is going to get attached to the constant. So everything just sort of moves over 1. That means that our final answer is 1x plus 3. All right? That's all there is to it. All right, that's it. It's really not particularly hard. The arithmetic, sometimes we mess up as we often do when we're adding and subtracting. But the nice thing about this is, again, even though it doesn't always work, when it works, it's way faster than long division. All right, let's take a look at the second example. Slightly longer one. I'm not going to write quite so much down for this. Okay, we draw a little upside down division symbol here. and we put these coefficients in for each of these terms. We put x cubed, x squared, x, and a constant. You don't actually have to write those things, but that just is, I'm explaining where you get these values from. So the first number is 1, the second one's -4, -6, and then finally -4. And I like this box right here. This helps me remember that that's the remainder. The next thing you do is you take this number right there and you do its opposite. And its opposite number goes right here, -1. That's where it's going. Okay? I'm not going to write the steps again, but I'll state them as I go through. Bring down the first number. Bring it down. It's a 1. Multiply -1 times 1. Put it right here, -1. It kind of goes this way. That's multiplying. Then you add. Okay, -4 plus -1 is -5. And you multiply again. -1 times -5, and that goes right here, +5. Alright, this one's a little longer than the last one. -6 plus 5 is -1, and then you multiply again. -1, one more time, this -1 times this -1 is +1, those crisscrosses like that. And then the last thing that you do is add one more time, and we get -3. Alright, way faster than long division. You have to know what this means. Again, we started with an x cubed, so we're going to go down by 1 power, 1 degree. This will be x squared, this will be x, and this will be our constant. This one will be our remainder. So our final answer to this problem is 1x squared minus 5x minus 1. And there's two ways you can write this. You can either write plus -3, put it over the x plus 1, or you can write minus and put 3 over the x plus 1. Either those are fine. Okay? So basically, I'm just going to work a couple more examples that have a couple of little tweaks in them, and to make sure that you follow all of the steps in the process. Okay? We're going to go put this one in. Again, x cubed, x squared, x, and a constant. And what happens in this problem is we run into that issue of placeholder again. We have to get that placeholder in. Well, it is possible to do long division without your placeholder. People usually can't do it right, but it is possible. You will not get it right if you don't use placeholders for synthetic. So I have to put a 0 right there for the x squared, then -2 for the x, and 4 for the constant, a box for the remainder. You take this number and you do its opposite. Since it says +1, I put -1. I will tell you what that does. That lets us add when we come down instead of subtracting. Okay? It allows us to add instead of subtract, and we make fewer mistakes when we add. Put a 3 here. -1 times 3 is -3. Add. Add. -3. -1 times -3 is +3. Add. -2 plus 3 is 1. Okay, then you multiply. -1 times 1 is -1, and then you add, and we have a remainder again. All right, we have to drop these each down by 1 degree. So this was x cubed. So this one is going to be x squared, x, and our constant, and our remainder. Okay, so last time I'm going to write all of that on there. So our final answer is 3x squared minus 3x plus 1, and our remainder is 3 over x plus 1. Just to make sure, this 3 comes from here, and this denominator is what you divided by right there. Okay? So one more where we have to do a placeholder. If you want to stop right now, this would be a good place to stop and see if you can set this one up correctly. And then come back in and take a look and see if you did it right. Or you can just take it as notes. X cubed, this time I use y, y cubed, y squared. There is no y right here. There's a y squared and there's no y, so I need a placeholder of 0, and then -10. You have to have that constant on the end. It has to be there. All right, and I'm going to divide by the opposite of this, not +3, but I'm going to put -3. And hopefully the arithmetic won't be too tricky. Bring down the 5. -3 times 5 is -15. 16 plus -15 is 1. Negative 3 times 1 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is positive 9. And negative 10 plus 9 is negative 1. Once again, we have a remainder. And once again, our power drops by 1. So I'm going to write down my final answer. It was y cubed at the beginning, so it's going to be 5y squared for our answer, plus 1y, minus 3 is our constant, and minus 1 over y plus 3 is our remainder. You may leave this minus where it is. If you prefer, you can put a plus here and put a negative on the 1 like that. All right, excellent. Now, synthetic division only works when you have a first degree binomial. That means it won't work if you have x squared plus something. It won't work. Nope. Or x cubed. It has to be just x. And the lead coefficient has to be 1. That means if the lead coefficient is a 2, this right here, then nope, it won't work. All right? However, we can do one little step at the beginning, and we can, and we have to do a little step at the end, and we have to not worry about fractions. They're not going to be terrible, and then we can use it. So here's the step that you do. This problem has this coefficient of 3. So what I'm going to do is I'm going to divide the denominator by 3, and I'm also going to divide the numerator by 3. When you take a fraction and you divide the top and the bottom by the same thing, then you have a fraction that is equivalent to what you started with. It looks different, but it is of equal value. So you can do the same thing with these messy fractions. 3x squared divided by 3 is x squared. 4 divided by 3 is 4/3. It isn't hard. And 1 divided by 3 is 1/3. Don't panic. I promise you it isn't going to be hard. 3x squared divided by 3 is 1x. And 1 divided by 3 is 1/3. So instead of working the first problem, we're going to work this problem, the second problem. All right? So let me set up my synthetic division here. My coefficients are 1, negative 4/3, and 1/3. On the outside, I do the opposite of this. That's a minus 1/3, so I put a 1/3. A reminder again, that's just to let us add instead of subtracting. It makes it a little easier. And I've made these problems so the arithmetic's not very bad. You shouldn't need your calculator, but get it out if you're feeling a little anxious. Bring down the 1. See, 1 times 1/3, not hard. 1/3. Again, I'm adding. They have the same denominator, negative 4/3 plus 1/3. If you need to go over to the side to do that, then do it. Is negative 3/3, and negative 3/3 is negative 1. It really turns out to not be very difficult. Okay? 1/3 times negative 1 is negative 1/3, and my remainder, I like to have that box rounded, is 0. Most of the fraction arithmetic that comes out in here is going to be about that level. It's not going to be super difficult. So your answer then comes from here. This is going to be x, and this is going to be your constant. Your answer is 1x minus 1. That's the answer to the original division problem. Okay? Second example. Notice that there's no m squared. So that means I'm going to need a placeholder. Okay? So first thing I'm going to do is rewrite this problem as a big fraction so that it's easier for me to see what happens when I divide the top and the bottom by 2. Let me just make sure you know why I picked 2 here. Let me go back. I think I sort of skipped this. I picked the 3 right here because this number was 3. And I want this number to be 1 right here, so I divide by whatever that coefficient is. All right, so on this problem, I want this number to be 1, so that's what I divide by. You have to divide the top and the bottom, and you have to divide every term. So 8m cubed divided by 2 is 4m cubed. 4m divided by 2 is 2m, and 6 divided by 2 is 3. See, that one didn't even have any fractions in it. In the bottom, you have to divide both pieces. 2m divided by 2 is m, and 1 divided by 2 is 1/2. In these problems, you're always going to get a fraction here, and sometimes you will get them here as well. So we're going to work with this problem, okay? Put my box, my upside down division, put 4, put my placeholder 0, this is for m squared, here, then -2, and then 3 is my constant. You have to have all of them. On the outside, for my divisor, I'm going to use -1/2, and then I follow the steps, bring down the 4. 4 times -1/2, not hard. 4 times -1/2 is -2, goes right here. 0 plus -2 is -2. Then I say -2 times -1/2, again, not hard, +1, goes right here. Add -2 plus 1 is -1. -1/2 times -1 is +1/2. Okay, so I got a fraction here. Might have a little bit more trickiness here. I need to add 3 plus 1/2. You know, really, 3 plus 1/2 is not hard. It's 3 1/2. Just isn't. Let's change it to a complex fraction, an improper fraction. 2 times 3 is 6, plus 1 is 7, and that's what we want to put in our answer space right there. Okay? So the fractions are not going to be any more difficult than what I just put right here. Try them without your calculator so you get better at it, and then pull your calculator out if you're feeling a little bit anxious. All right, there is also a little trick at the end of this problem because it has a remainder. There's nothing tricky about this. This is m squared, this is m, this is the constant. 4m squared minus 2m minus 1. But we have to do a little work on this remainder. 7/2 divided by, we have to put in this, the actual problem we work, we have to put m plus 1/2. But this is horrible. Look at all those fractions. That even makes me anxious. And so I want to get rid of them. We're going to back up and do the reverse of what we started with. We're only going to deal with this right here. We're going to multiply the top by 2 and multiply the bottom by 2. We're not going to multiply these beginning things. They're not going to change. This is going to stay 4m squared minus 2m minus 1. But then I'm going to multiply the top and the bottom of that messy fraction by 2. When you multiply 7/2 by 2, you get 7. And when you multiply m by 2, you get 2m. When you multiply 1/2 by 2, you get 1. This should look like the original problem right there. Okay? All right, one more example. And we'll get it together. The next one's really just to put it all together one more time. It's not going to have anything different in it, it's just more practice. Okay? So first, write it so it looks like a fraction. This number is not 1, so we have to divide everything in the top and the bottom by 2. Okay? Hopefully, most of it won't be a fraction. We end up with one fraction in the numerator. Everything else is double integers. And in the denominator, we get x minus 1/2. I just divided every number, every coefficient, every constant by 2. All right? And I'm going to work this problem. Take my box. I'm going to put a 1/2 on the outside. Oh, I think I left the square off. 2x squared there. That's right. And we've got no placeholders this time because everything's full. That's x cubed. Oh my goodness, I copied this completely wrong. Hold on a second. Okay. So, I'm sorry, let me back up here. This was an x to the 4th. Don't make the mistake that I just did. That needs to stay an x to the 4th. Okay? So, I do have a placeholder. So, this is x to the 4th. The next thing has to be x to the 3rd, and there's not one, so I have to put a 0 in. Then the next thing has to be x squared, -2, then x, 1/2, make the box a little longer, and at the very end, you have to have your constant. At the very end, goes right there. Now, you don't have to write all this at the top. That doesn't have to be written there, but you have to take it into account. All right. See if I can get through this without making another mistake. Bring down the 4. 4 times 1/2 is 2. 0 plus 2 is 2. 2 times 1/2 is 1. -2 plus 1 is -1. 1/2 times -1 is -1/2. 1/2 plus a -1/2 is 0. That's the first time that's happened. 1/2 times 0 is 0, and 2 plus 0 is 2. So all those steps are exactly the same, and the fraction arithmetic is not difficult. We started with x to the 4th, so this right here is not going to end up as x to the 4th, it's going to end up as x to the 3rd. And our answer is 4x cubed plus 2x squared minus 1x no constant. If you want to put plus 0, you can, but then you need to get rid of it. So there's no constant. And then our remainder turned out just to be 2 over x minus a half. Remember, when you're doing these fraction problems, you have to put it over the problem you actually worked, x minus a half. And this isn't quite as bad as the first one, the last one we did, but I still don't want to leave a fraction in a fraction. So I'm going to multiply the top by 2 and the bottom by 2. Copy all of this over again. They're not affected. They stay the same. When you multiply 2 times 2, you get 4. When you multiply x times 2, you get 2x. When you multiply 1/2 times 2, you get minus 1. And this should end up being the divisor from the original problem. That's it. Hopefully the homework won't take too long. I think it's about 10 problems, and I've given you a couple of reminders. So good luck, ladies.